Yeah, today we are going to start with physical and chemical change. So first of all, I want that you should be familiar what do we mean by the properties. See, every substance what we come across has certain characteristics or qualities in it due to which it can be distinguished from the other substances present around that. So that means any substance has got certain characteristics, certain qualities it fulfill actually, due to which it can be distinguished from the other. It means that it is actually, those properties actually govern the identity of that substance. Right. So we have two kinds of properties of any substance. So those characteristics are called as those particular characteristics or the particular you can say the qualities that is possessed by that substance is called as its properties. Right. So we have two kinds of properties. One is physical properties and the other is chemical properties. Now, how we can distinguish between these two properties? Just listen to it carefully. I am talking about the properties. I am not talking about the changes. We will be taking up changes later. For this moment, I'm just making you familiar what actually the properties is. So properties are the qualities or the specific characteristics which are possessed by any substance. Right? They are of two types. Any substance has two kinds of properties. One is physical property and the other is chemical property. So the physical properties are those which can be judged by simply looking at the substance, right? Like for example, if I ask you or if I talk about the physical property of this marker, then what you'll say? You'll say it is white in color, as it appears to be white and blue combination, and moreover you will say that it is solid at room temperature, and by seeing it, by looking at it, you get to know that yeah, it is hard also. Yeah, what will be its density, what will be in melting and boiling point. So all those properties which can be concluded by just looking at the object is called as physical properties, right? And for few examples I'll write for you, and I think you have got it actually what the physical properties are, but still I'll write what do you mean by physical properties. Physical properties are those which can be judged just by the looking at the object. That can be the hardness, can be the odor that you can smell it, or the color you can see it, the melting point, the boiling point. These all are also, we include density, and a lot of properties are included in this physical properties that we can easily judge just by looking at the object, right? So all those properties which can be judged just by looking at the object is called as physical properties. They come under physical properties. And second, now we come to chemical properties. What are actually the chemical properties are? So we get to know the chemical properties of a substance by reacting it with some other substance. By reacting it with some other substance. By reacting, we are actually changing the composition of the substance, because when any substance reacts, its composition gets changed, and we get to know that what kind of nature it possesses and whether it will react with certain substance or not. And the substances which we use to react, which we use to know the chemical properties of a substance, are generally acids, metals, non-metals, indicators. We have phenolphthalein, this methyl orange, litmus paper. So these are all that when we add that given substance to any other substance, acid, base, alkali or indicator, they give about a certain kind of change. Sometimes the change happens, sometimes the change doesn't happen. So that change indicates that yes, what is actually the chemical composition of the substance. What it will do when it will react with this, when it will undergo a change in a composition by reacting with some other substance. So these all come under chemical properties, right? So properties are of two types. One, physical, you just judge by just looking at it, and the chemical you judge by just reacting that given substance with some other substance. So we have two kinds of properties. Similarly, we have two kinds of changes occurring in nature. That means if I am supplying energy to any substance or a matter, I can say, so two kinds of changes are generally observed. So these changes are classified into two categories: physical change and chemical change. So two kinds of changes that occur around us is physical change and the chemical change. Now we are going to study what actually the difference between these two changes, that the changes have been classified into these two broad categories. So just try to figure out the difference between them. So just carefully look at the board. So we have two kinds of changes. I am writing here again. The physical change, now we are taking up the change, right? Those were physical, those were properties. Now we are talking of the change. So we have two kinds of changes that are generally occurring when matter is supplied with energy. So two kinds of changes are there, physical change and chemical change. Now what is it exactly? So I am taking an example so that you will get these changes understand in a better way. Right. So I am taking an example. See, I have taken a beaker which is filled with water and I am just adding a spoon of sugar to it. This is water and I am adding a sugar to it and I am just stirring it. Right. So after a few minutes you will get to see a solution which will be no longer you can say the neutral one. Now it has become the sugar solution and it will start tasting as, and its taste will become, now it will be sweet, right? So earlier there was no sweet taste, no bitter taste, it was just neutral taste. But now it is, earlier it was tasteless, but after adding sugar it became a sugar solution and it started tasting as the, you can say, the sweet one, right? So this is the example of the chemical change, right? This example which I have illustrated is a chemical change. And for physical change, I am taking an example, like for example, this is, we'll do this topic again, just look at the board. We have two kinds of changes, one is physical change and the other is chemical change, right? We are just going to figure out the difference between them. The example which I am taking is when sugar is dissolved in water, it turns out to be sugar solution and it starts tasting as sweet. This example comes under the physical change, right? So if I am taking an example of chemical change, suppose I am taking a paper and I am burning it with the help of burner, right? So what do we see? It turns out to be ash, the paper turns out to be ash and along with it we get CO2 and water vapor plus energy in form of heat and light. See, so we have two examples. In one I am dissolving the sugar and after dissolving I get a sugar solution which start tasting as sweet. And in the other example, as a chemical change, I have taken a paper and I have just burned with the help of burner, and what happens, it just burns into form ash, and along with that carbon dioxide, water vapor, energy in form of heat and light is liberated. Now we will look for the difference, that what actually the difference between the physical and the chemical change. So when we are dissolving any sugar into water, what happens? It is just the change in the state of substance. It is just the change in this state of the substance. Otherwise, the identity of the substance remains as such. As you can say, as you can look, that the sugar remains as sugar and the water remain as water. They both just unite to form sugar solution, but still the identity is maintained in it. And similarly, if I take an example of this chemical change, now we'll look for these 2 points. What is happening in case of chemical change. So when I am burning the paper, it is just losing its identity because it is now being converted into ash, right? So that means identity is changed. Now it is no longer it will not no longer behave as paper, it will now behave as ash. So that means the identity of the substance is changed, and moreover there is a change in the state of the substance as well. So state of substance is also changed. So now coming to the other point, can I separate sugar and water from each other, like from the sugar solution, can I separate the sugar and water? Yeah, we can do it. So that means this change is a temporary change. We can easily reverse it. How you can separate the sugar from the water solution? We can just separate by the process crystallization, and as well as we can separate by the process evaporation. When either it is a sugar solution or we take a salt solution, what happens? Water has the property to get evaporate. So the water will get evaporate leaving behind the crystals, whether it can be the sugar solution also, it can be if we are taking an example of salt solution, then also the water can get evaporated and leaving behind the salt. So that means this change is temporary, it can be easily reversed. But when I take an example of this chemical change, can you get the paper out of ash? No, we can't get the paper out of ash, so that means this change is permanent. Now this paper has been permanently converted into ash, and we cannot get the paper back from the ash. So that means this process is permanent and it is irreversible. It can't be reversed. Moreover, now I am taking into the consideration that what is happening to the mass. So when we are dissolving sugar into water and we are getting the sugar solution, so the mass of substance remains unchanged. There is no change in the mass of the substance. The amount of water you are taking and the amount of sugar you are adding, the both when they are just added, the mass is equal to the total mass is equal to the total mass when we get the sugar solution. So that means there is no change in the mass. But when I am talking about this, I am taking the mass of paper separately and taking the mass of ash separately, then there is a change in mass, because some of the mass is lost as the energy in the form of heat and light and as carbon dioxide and water vapor. So that means the total mass gets changed. So that means there is a change in the mass. Now I am taking into the consideration the energy aspect. So when we are talking of the physical change, the total energy remain constant. So as we know that energy is always constant, energy can neither be created nor be destroyed, it can be just converted from one form to another. But in this, when a substance undergoes a physical change, energy is neither released nor absorbed. So that means the overall energy remains constant. The energy is neither absorbed nor released. It is just used in the change of the state, otherwise it remains the same. But when I am talking of the chemical change, see in this example, when we were burning the paper, we were getting the ash, CO2 and water, and along with that energy was liberated. So that means now the system will have less energy as compared to the energy it was possessing before. So that means there is the energy changes that are occurring when a substance undergoes a chemical change. So these are the difference actually that exists between the physical and the chemical change. Just have a look once again. Physical change is that in which the state of the substances change. In this, the state of the substance is just change. In this, the state of the substance is not change. It is just the identity, the whole identity gets changed actually. In this change is temporary and can be reversed, but this change is permanent and it cannot be reversed. It is irreversible. The mass of the substance remain unchanged. The mass is changed. This mass you can take in the broad category which is used for this mass is the composition. So we can use the word the composition or the mass. So composition remain unchanged. And in this the composition, or you can say mass, gets altered, it gets changed actually. So energy is neither released nor absorbed, but in this case sometimes the energy is absorbed, sometimes the energy is released. So that means it is undergoing the energy changes. So these are the two categories in which we classify the change. So we'll take a few more example, like if I say freezing. So what is freezing actually? Freezing means the liquid is getting freezed, that means water is getting converted into ice. So in which category you will classify that change? Obviously into a physical category, because only the state is getting changed, otherwise the identity remains the same, and moreover the whole this thing which we have summed up is obeyed by that process freezing. So that means it comes under the physical change. For example, few more example we will be taking, like if I say dehydration. Dehydration means the loss of water, right? The loss of water is called as dehydration. So under which category this dehydration comes? Like if I take an example, I'll take one more example. See, we have copper sulfate pentahydrate crystals as CuSO4.5H2O. This is copper sulfate, penta means 5, hydrate means this is 5H2O, water of crystallization, which is attached to the copper sulfate. So the color of this solution is blue initially because due to the presence of this water of crystallization. Now what I am doing is I am adding concentrated sulfuric acid to it. What does this concentrated sulfuric acid do? It acts as a dehydrating agent. So either I can use this dehydrating agent or I can simply heat it. So by either of the way, what it is going to do, it is going to lose its water of crystallization and it will now become from hydrated salt to an anhydrous salt. You know what change is observed? Earlier it was blue in color, but now after the reaction it becomes, the blue color just gets discharged. So that means the chemical change has been occurred. So this is how the chemical changes. So when I am talking about the dehydration means the loss of water. So even the loss of water is undergoing a chemical change. So it is also a chemical. It comes under the category chemical change. So this one more example I'll take. Suppose you are taking a curd and the milk and you are adding a spoon of curd to it, just stirring it and just keeping aside. What happens when you look at the flask in which you have done that? You'll see that it turns out to be curd. So that means that is also a chemical change because you cannot convert curd back into the milk. Can you do that? No, we can't. So that means it is also a chemical change. It can't be reversed and even the properties of the substance has been changed now. So any substance which is undergoing the change of the state, identity is losing, temporary reverse change, mass is getting altered, energy, total energy is neither released, absorbed. So that comes under the physical change, and whenever it is going through these processes, these things which we have summed up, so it is undergoing a chemical change. So this is how we classify the changes into two categories, that is the physical change and the chemical change. Now we will be taking up the new topic, that is if I want a chemical reaction to occur, that means if I want a chemical change to occur, so what are actually the factors which are responsible to bring about that chemical change, right? So we are just looking for the factors that influence the chemical reaction or a chemical change to occur. So what are the factors? What are the factors that actually influence the chemical change? If we need a better chemical change or if we need a chemical reaction to occur, so there are certain you can say the factors that influence that the rate of the reaction and also make the reaction happen, right? So first factor which is responsible to make the reactants in close contact. Now what is it? See, if I want that the milk should turn into the curd, so what I am going to do? I am going to add a spoon of curd into the hot milk, right, and slightly hot milk, and then what I will be doing, I will be just stirring it so that it gets uniformly distributed in the milk. So then the reaction will occur and it will change into curd. Right. So do you think that it can also change into the curd if I keep the milk here and if I keep the spoon of curd away from both are away from each other? So can you think that the reaction can happen just by keeping the things along with them? No, they can't happen. We have to mix those things uniformly so that the reactants should come in contact with each other so that their old bonds are broken and the new bonds are formed. So that means the reaction to occur, for the reaction to happen, there is a need that the reactants must come in close contact with each other, right? So that means the first criteria, that means the reactant should come in a close contact with each other. So that is why sometimes we often get a question that for example we take a magnesium ribbon, right? Magnesium occurs in the form of magnesium ribbon and we also can get in the form of magnesium powder also. So if I ask you that which is efficient out of magnesium ribbon and the magnesium powder, which is efficient in undergoing a chemical change? So if anybody asks you like this, so there should be a quick response that the state in which there will be close contact will be a better one, will be efficient for the chemical reaction to occur. So out of magnesium ribbon and magnesium powder, which is going to be have close contact with each other, obviously it will be happening in case of the powder, because they are in the powder form, they can be more closely you can say relate with each other, come closer to each other, more bonds can be broken and more new bonds can be formed. So that means the reaction which is occurring at the amorphous form or at the powder form is more efficient rather than taking in a pure solid form, a three-dimensional structure or a crystal form, you can say. So that means for the reaction to occur, there should be a close contact. Sometimes to make the close contact happen, we generally use like we add, you must have heard about the reaction between zinc and the dilute H2SO4. It is just a method to predict the identity of the metal. Like if I give you any sample and I ask you that whether it is metal or not, state any reaction for it. So we just add an acid to it, evolution of that H2 gas with popping sound indicates that it is a metal, right? So what happens, we don't take a zinc rod, we actually take a zinc granules in that case. So what we do, we take a conical flask and we add zinc granules to it, and then we add dilute H2SO4 to it. So why am I taking zinc granules? Why am I not taking the zinc rod? It is just to increase the rate of the reaction. How it is now increasing the rate of the reaction? Because the zinc is more efficient in reacting or carrying out the chemical reaction when it is used in a granular form. So whether you use it in a rod form or in a granular form, the reaction will happen. But for the reaction to efficiently happen, there should be a close contact between the reactants. So as on the whole, I just want to tell you that the reaction happen in a better way when the reactant come close contact with each other. So it can happen in a better way when it is taken in an amorphous form, like instead of zinc rod, if we are using zinc granules, the reaction is going to be in a better way. So the first criteria to bring about the chemical change, you all know now that the reaction should be in close contact, reactants should be in close contact with each other. Right. Second factor that influence the chemical change is that there should be a supply of energy. There should be a supply of energy. Now why this supply of energy is required? See, when we are supplying the energy, this energy can be in any form. It can be in form of electric current, it can be in form of sound, it can be in form of simply heat, or in any form we need to supply energy. Now the question must be striking your mind that what is this use of energy? This energy will make the reactants to break their old bonds and help them in forming the new bonds. Because in a chemical change, always a new substance is being formed. So for a new substance to be formed, the old bonds have to be broken and the new bonds have to be formed. And this happens only at the cost of energy. Because for breaking bond, we need energy, and then when they are making new bonds, sometimes they need energy and sometimes they liberate energy. That depends accordingly on the reaction. So the second criteria which is required is the supply of energy. It can be in any form. I am just summing up the few examples for you to make you understand in a better way. See, the supply of energy in the form of heat. So any example we will take in which we supply heat for the reaction to occur. For example, CaCO3. See, this is calcium carbonate, commonly called as limestone. So when we heat it, what happens? It undergoes a change and it forms lime and carbon dioxide. So this reaction is occurring at the cost of supplying energy in the form of heat, right? Another example in which the supply of energy in different mode, for example, electric current. Now, the example which is striking in my mind is the breaking of H2O. Water actually is a stable compound. It does not get break into its constituents easily. But when we supply it with electric current, it gets split into its constituents. So the splitting of water by passing electric current, in this it is obviously a chemical reaction, and how it is occurring due to supply of energy in the form of electric current. Similarly, the supply of energy, I am taking one more factor, pressure. So for pressure, the example which is striking in my mind is the Haber process. That is the formation of an important compound, that is ammonia. So what happens? Ammonia is formed when we apply the pressure, and the pressure is approximately 200 atmospheric. So in this, the energy is supplied in the form of pressure, right? Few more modes in which we can supply the energy that is striking in my mind is, you can say, the catalyst. You know what actually the catalyst is? It plays a very important role whenever it is present in a reaction. See, catalyst is a substance which will just increase the rate of reaction without undergoing any change in itself, right?